So today's session is on basically looking at application health in a slightly different analogy. Just really looking at vital statistics, just trying to use that to determine if an application is performing healthily or not. My name's Dani Beaubien. I've been doing 4D stuff for forever. My primary focus is on vertical applications, and the last 10 or 15 years, mostly web-based applications. So it's many servers over different locations. And so our biggest challenge is that we're not just monitoring a single server, we're monitoring many. And then how do we know when it starts to misbehave? Often we find out after the fact. And so this is really just an approach that was taken to try and determine the conditions that are occurring for an application to start behaving poorly, or when is it just simply the users in a bad scenario where their machine needs to be restarted or whatever the situation might be. So it starts with the analogy of a patient walking into a doctor's office and they say, I don't feel well. It's very vague. That's usually what starts it all. So my machine crashed, my window disappeared, the printer's not working. It's the same thing. And so a doctor hears that and they have a basic understanding of what patients are. They understand that patients, like our servers, are closed systems. They have fixed resources. There's a certain number of inputs, there's a certain number of outputs. Often patients don't understand what was put in. They don't understand necessarily what came out. So they just talk about their perceptions of symptoms, and it really doesn't speak to the cause. Doctors have methodologies that they've developed over time and how they approach these scenarios. So it starts with, what's your blood pressure? What's your heart rate? What's your temperature? Did you go to the bathroom today? These basic questions that they use to start assessing. And what they're really doing is they're looking at, okay, we have this massive system. What can I, take away that's not the problem? Oh, your heart's still running. Okay, good. So that's fine, and so on. And so as they go through, they use these tests, and these tests get more and more focused. And then they start narrowing into places where there are some anomalies or abnormalities. And then from that, then they start to make assessments. And so what we need to do is try and develop our own set of methodologies and how do we approach health of our servers. And part of our challenge is that each of our applications are unique. They have their own strain on the system's resources. They consume things differently. There's network issues, disk issues, memory, I/O access to the database, and so on. And so it's hard to bring one type of application that's been built to be able to use the same metrics necessarily. They don't necessarily come across. And so often what we have to do is we have to use research and time to figure out what are those measures that we can use and that we can count on, so KPIs, key performance measures, indicators, that we can use to count on to indicate abnormalities. So if in my situation, we're all based on web applications, so we have this basic abstract metric is we'd like to have pages 300 milliseconds on the server side generated 85% of the time. So when it starts to drift outside of that window, then it's like, there might be an indication of something's going on. Well, maybe it's just there's twice as many people as there's normally on. And maybe it's performing great. So it's trying to figure out what things to start paying attention to, what's normal, what's not normal, which takes time. So what I call it the M&M method. It's measure and mitigate. And notice it's measure first. So the first thing we need to do is we need to understand what is going on inside the system. So then there needs to be ways to measure the system. So in our case, we're dealing with web applications. So we do a lot of performance on how long does it take to generate a page. There's parts of a page as well. So we've broken it up into components. So we're understanding of what's common across all pages and what's not. And then we measure that over a long time. Like we've got years of measurements. And so we understand peaks. We know what valleys are. We know when it's slow. We know how the cache behaves. So we've done this research and we have a sense of what is normal and when things start to break down. Yeah, and then once we've got that, then it starts to help us figure out, okay, all of a sudden I've got a part of the application that's starting to exhibit stress. then it helps me narrow down to where in that part I can now ignore other parts of the system. Is it based on printing? Well, then I can focus on printing, as opposed to the pages that are dealing with printing. And so you want to have these measurements that they help you narrow down as to where the problems might be, and in more particular where the problems are not, because the problems are definitely not in more places than they are in places, if that makes any sense at all. Yeah, so measure before you mitigate, which means you really need to understand. And it's deep knowledge, and sometimes it's deep measurements. It just depends on what it is. And really the ultimate goal is to try and find the issue and treat the issue, as opposed to listen to symptoms or users complaining that it's slow or whatever the situation might be. And so I just want to reiterate, our systems are closed systems. We have a fixed amount of resources. It's very difficult without doing extraordinary effort to change some of those fixed resources. Yes, we have things like virtual machines and stuff like that, but it's still a fixed resource. If we want to start adjusting the size of machines, then there are things that are running that are changing what that fixed closed system is. But then when you change a virtual machine, now you're in a different system. You've changed systems, but it's another closed system. So, and then it has got different behavior. So all of these pieces contribute to the stress of the system. And when one of these components, so let's say I've got a trigger that's behaving very, very badly, it can infect the entire system with poor performance. And so that's the closed part, is that they're all interrelated. And so the idea is to try and tease out that, I'm using a sum function in one particular place, and it locks up my database for 2.5 seconds. And then outside out, you just see all of a sudden I got this massive spike in page render times, and how do I figure out where it is, right? But I might be serving, let's say, 10 pages that particular 2.5 seconds. All of those 10 pages will show a spike in performance in render time. So trying to tease out what part of that actually caused the problem is part of the challenge. Yeah, what is healthy? So this is, I don't know if you've done any sort of performance measurements or really looking at peak loading, is often what we'll see is that the application will be performing nicely, and at some point it starts to get stressed and it hockey sticks. And the question is that when we're running our applications productions, we don't know where we are between that and where it starts to hockey stick. We just know that it's good. So part of what we would like to do is we start paying attention over time, and we'll start seeing those hockey sticks, and we start getting understand where we're getting to where our peak load is on parts of the application. And then you can start fine-tuning, I need more memory, or I need a faster disk, or you know what, I probably should separate this into multiple servers, or whatever the case may be. And then once you have a sense of some of your measurements, you can use performance tools to add load, and then you can find out what is my peak. Because typically, let's say, okay, I've got 10,000 users in a month, and it's 20 business days in a month, and it's 8 hours a day, so I can't just divide that up across the hours. I know that my users, they have a peak time at 11 a.m. and 1 p.m., and that typically about 30% of the day's usage is in those two times. So I know where my peak numbers generally are. I know that I deal with vertical applications in the school system. So at the end of the school year, there's heavy printing. So they'll be printing 2,000 print jobs in a day as opposed to 200. So I understand when the peaks come in, and I can start paying attention and deal with it accordingly. And so this is a key question to ask, because it's individual. Okay, so then I'll talk about what I've done. So the company that I contract with is a company called InfoHandler.com. They are a vertical market application for school systems. So they target basically helping therapists who provide special needs services into the K-12 students do some of their paperwork. And so it's a web application to collect basically the due process stuff that they need to do for billing. This is our environment that we're dealing with. So we have our users, there's Internet, Firewall, Apache. Anything in pink are test servers. Anything in the dark gray are production servers. And then we have our, what I call heartbeat, This is the monitoring application, the monitoring component that we have. And so we have a central piece in the middle that monitors all the applications. And all the dashed lines are just kind of background communication going around. All the servers are essentially independent of each other. Some of them are the same application and some of them are variants of the application, but they all run independently. Okay, so it's enough of slides. So most of the time I'll be spending going through our dashboard. So this I'm showing you production systems here. I haven't shown you me logging in. We have single sign-on between all of our servers for our side, so you won't see me logging in, but there are all logins. It's just single sign-on. So this is showing production side. There's the non-production, the training servers. So can you guys see in the back, or do I zoom in and zoom out? I'm not sure. Zoom in and zoom out. Okay. So what I've got here is I'll just pick this line. So in this server, there's two servers that are running for Colorado. There's Colorado 1, Colorado 2. I'm showing, and this should work. There we go. So I've got a little icon. So this is a tool for me as a database administrator and developer to be able to go in and assess what's going on quickly. I can see the versions of all the components that we have. So these are components that we've developed in-house. So there's a versioning system that they communicate to each other. I know the current version, and this is our internal versioning number of what's on that server. I know how many users have been active in the last 5 minutes. I know how many users are actually logged on right now. I know how many pages have been served in the last 5 minutes. Okay, good. No, I can't scroll. This is the cache size that's allocated to it. I can see how much of the cache is being used, so 97%. This is showing how much physical memory that server application is consuming on the machine. So these are virtual. So there's Colorado 1, Colorado 2 actually are running on the same hardware, but it's two kind of shared terminal things. So they're shared, but they're not shared. Actually, no, that's a lie. These ones aren't the same. Oh yeah, they are the same. And this is showing how much virtual memory. We ran into an issue where there's servers were mysteriously crashing. We couldn't figure out why. And it turned out the reason why was because there wasn't enough quote unquote free memory on the machine. So anytime it gets below 1.5 GB, there's basically a big orange bar that appears here, and it tells you that we're getting a low memory, and if it gets below 1 GB, it goes red. And below 1 GB is where it starts to get into crashing territory. So that's a sign that somebody needs to go in and cycle the server to free up the memory. It turned out that there was a memory leak, and we were nailing it dead on. So we solved it, but we still leave the warning in there. Got to go all the way out. Okay, so we do nightly backups. So this check marks tells me that last night's backup was successful. And it's based on the 40 commands and get last backup. This is a dash because the version of the component that's on that server isn't new enough for that. This tells me how many days in the past a successful data verify check was done. It's done every week, and if it fails, and I left one failed, I get this mark down here. And so that's telling me that that data check actually failed. It's telling me some blob is invalid or something, I don't know. This is telling me how many pages have been served since the server restarted. So it's not in a day, it's how many times since restarted, how many print jobs have happened since it's restarted. And then here is, I don't know, it's a little graph that tells me the speed. So each one of these blocks represents the 85th percentile, not 80th percentile like it says in the header. 85th percentile of the average, or not the average, but all of the pages averaged out, 85th percentile of how long it took to generate the pages. If it's green, it means it's less than 300 milliseconds. If it's orange, it's between 300 and 600. And if it's more than orange, if more than 600, it goes red. So at a very quick view, I can tell you, I can say, okay, those all look reasonable. And then now over time, we have a sense of what a typical day's performance is like. And then at the end here, it tells me how many days. If you have any questions, please just throw it out there, okay? I'd rather have questions live and then...
How often do you recycle and restart the server?
Which server? This one that's monitoring or the other servers?
Well, the ones we're looking
I'll repeat the questions. Yeah, so For the production server, the CO1, CO2, the only time they're generally cycled are two situations. There's a monthly maintenance that's done on a schedule. So basically the system's brought down. There's a formal data check, verification that's done and cleaning up any issues. That's one. And then once a month, there are server maintenance where they go ahead and do the Microsoft updates. So generally that's the only time, or when we're actually applying an update because there's a code update. Yes?
On the ones that fail,
Like,
do you get notified via email or some messaging way, or do you have to, as a human, have to monitor?
okay, yeah. So for these ones that fail, we don't have any sort of automated notification. So generally, for me, this is open all the time. There's another one of like the CEO, he has this open all the time, so we're monitoring all the time, so we know what's going on. This little mark here is, we have multiple logs, and so we have what we call an error log, and then we have our normal application logs. And so this is telling me there's something in the error log. And so we found out there was a lot of things going in there, so we've been spending over the last year or so cleaning them up and removing the scenarios that were causing things to go in, so we're cleaning them up, but there still are some left. But yeah, so generally there's no active notification from an email side. We do have monitoring, things like pingdom is used to keep if the application is returning, responding to HTTP requests, so that comes through text messages, but there's nothing from this system. Yes?
How often do you verify the database? Once a month, you said?
So we verify the database manually once a month.
Once a month.
This does it every week.
Oh, every week?
Yeah, and then there's a bug tracking system on here, and it's done daily because it's fast. The problem is that like one of these systems is like 45 gigabytes, and so it's 8 hours to do a data verify. It's a back-end system, but it's still 8 hours. That's too long. For these systems, they range anywhere from an hour to 2 hours. So it's too long to take it offline at night.
How about compact?
That's once a month. That's part of the manual process. Yeah, we do a compact. Yeah.
So on the database verify, I guess I'm troubled. I don't do it on a routine basis. How often does it turn up a problem?
Okay, so let me flip that question around and say how often to do a data verify. Every time we've had a problem where the data file freaks out, we've gone back at least a week and done a bit of a data verification, and it's failed. So we do a data verification every week. I would say you need to do it regularly, and I would say you automate it because there's code. Like I'm using, there's a routine to call. You pass it a callback routine, and then the callback, then it just simply collects the data, and if there's issues, it captures it, and I throw it in a log, and it becomes part of a JSON thing that comes back here. It's easy to log and capture the information. The only thing is it brings the database offline, basically, for that time.
But that's unworkable if my database is, the smallest one's 300 gigs, and you can't verify that.
So we do our database verification that's through this system happens basically Friday night, 3 in the morning. So all the systems, and we're lucky enough that we're dealing with school users, so we have our service agreements basically say 7 a.m. to 9 p.m. And so outside of that, we're not guaranteed to be up, so we just make sure we're outside of that and it finishes it before it's done. And there's no guarantee, they know that on Saturday mornings there's maintenance that gets done, and so they're very tolerant of not having access if it runs longer. Yeah, so it's worthwhile doing at least once a month. And more if you can. We're fortunate that our systems are small enough that we can do it more. But on the system that takes 9 hours, I do it once a week. It's still done once a week. It just goes offline. And the systems that rely on it, it's all back in communication, so it knows, and they just queue up what they need to do, and then they let it go when it comes back online. Okay, so this is the summary view. And so what this application does is every 5 minutes, it contacts each server and basically says, hey, are you alive? And it says yes, and it returns a JSON object back with stats in it. Okay? From that, excuse me, what I can do is, we'll go into CO1. So this is the configuration for this server. I have, when my memory warnings start to show, So when it's below this number here, then it'll go red or orange depending on it. I also have this. This is, oh, I should do that. Whoops. Sorry. No, let's see the label. There we go. Database cache file to set. Thank you. R16, V16. So there's a command that lets you set the cache dynamically. So this application now sets the data cache on the remote servers, which is fantastic. So I can monitor and I say, wait a minute, there's an abnormal load, or I know something is coming. I can just go ahead and say, you know what, I'm going to add a gig. Because we've had situations where the administrators have come in and said they need to do a bunch of reporting, or there's some sort of big massive reporting period. We just add 2 gigs to it. And then 5 minutes later, all of a sudden the server has 2 more gigs, and then let it do its thing. And the next day I go in and I knock it down 2 gigs, and it doesn't have 2 gigs no more. It's awesome. It's fantastic. So it's dynamic. I can also start playing with things. So during the day, if one of the servers starts misbehaving, I can tweak cache a little bit to see if it makes a change. And then there's some stuff that helps me make that decision, and I'll show you. So right now, this is just on this side. So where do I want to go? I am going to go to, I'll go to the data checks. This is showing each one that's passed. So I've started capturing this information because I'm less concerned about past data checks. I'm actually way more concerned about failed data checks. And I'm more concerned if a particular server has a consistent history of failed data checks. So I'm starting to capture this information. This is new as of a couple of months ago. Which is useful. The other thing I'm capturing is I capture, let me go over here again. So every time the server starts, it collects all the versions of the components. These are our in-house components, as well as a version of 4D, and this is communicated back. So that means that I have a complete history of all of the updates, code updates that have been applied to this server. So this is not server restarts, this is code updates. So we often get a situation where on this date we had this problem and we can't reproduce it, so now we can go back to our archives, pull that version out, try and reproduce it, confirm we can produce it, and then confirm that it's been fixed or not fixed. So it gives us options. But sometimes we have to go back and saying, you know, I need this version because I need to run this data file against that code and redo this report because we have some sort of audit event thing that we have to fulfill. So this helps us know exactly what's going on. Part of this also is I'm capturing all the starts and stops. And so this is done by the local system. So I know, so here, oh, I should actually use the mouse pad, it crashed. It wasn't a gentle shutdown. So now I have over time, I know how many times the system is crashing. Once again, I'm looking for a pattern. So we had a server who was exhibiting consistent crashing, and it turned out that the data file, there was something in the data file, there was bad data. And so we basically had to rebuild the data file, but it wasn't coming up in anything else. But it was because there was so many crashing that we then were able to figure out that there was a real problem we need to look into. Cache flushes. I capture the current cache usage, and I try and watch for when the cache drops, when 40 has flushed. And when there is an abnormal number, in this case 11, there's something weird, unexpected going on. There's an indicator that shows up on the summary screen. And so my personal target is basically sub 5, 6 cache flushes a day. Anything less than that is fine. When it starts to climb up more than that, we start to see it affect performance. And that's based on our own feelings. We're running in hosted environments, which means they charge you for everything. So we're running as very little memory as possible. So, you know, we're not going to throw 20 gigs in a cache. Forget about it. You know, we're going to throw 4 on a 20 gig data file, and it runs just fine. Actually, I flush the cache every night, which I'll show you. Upgrades, data checks. Yeah, I showed you that. And because I have starts and stops, I can calculate uptime, which is very cool. And so I've got business hour uptime, and then I've got over the 24 hours. So I know every time, every minute, every second. Now I'm only checking every 5 minutes here, but the server itself, when it starts and stops, it's capturing into a record when I started, when I stopped. and it knows that if it didn't stop gently, it crashed, that the old record isn't closed out. So, and it's reporting back to here. So I can calculate this. So now this is something that the business users can then use to say, one of the customers, administrators is complaining the system's always crashing, and they're like, it's not. Like, what are you talking about? So like it gives fuel to go back and find out, is there really a problem? Yeah, which is very interesting. This is the JSON that I'm using. Unfortunately, it's harder to scroll. Oh, here, let me do the plus on this one. So this is the JSON object that's coming back. I've got it versioned because this is a production system. Some systems get updated regularly. Some systems, it could be 5 months behind. So I'm very careful. And so this application, when it's collecting, it knows which attributes are in which version of the object. There's my verified data file, backup, the versions of the components, environment. We have test environments, so it's aware of what's going on. You can disable the login on the client side, on the server, on the remote server, so then it doesn't let any web attributes. So it tells me what's going on, number of user sessions, the URL, free memory, and so on. And then here's the server events, the last started and stops. I don't know about you guys, but we tend to move data files around between production and test. And so we've had to be creative. So this GUID represents a unique start and stop. And then that combined with the production, the environment variable, whether it's testing or production, is then unique to each server, which is interesting. Okay. Whoops, sorry. Okay, is there any questions on this part of it? This is just on the server side, on the summary side. Okay, so what we're going to do is we'll jump into this one. Sure, it doesn't really matter. So now what we're doing is now we've gone to one of the servers and we're looking at its local heartbeat, what we call the heartbeat. So this now gives me access to the information that's being captured locally, and it only pertains, in this case, it's to CO2. So we have our app logs. So this is just a bunch of whatever messages that are going out. We actually have a number of logs. And so that's all the logs from today, so I can access any of those logs for whatever the purposes might be. This is that error log that I was talking about, so they're not critical errors, it's just things that I've decided I need to see, and so some of them are useless. Oh, there you go, so I can see somebody's trying to, up to no good, trying to hack the system, doing their usual. So those are really interesting. It's always at between 2 and 3 in the morning. We have users. So this is showing us, we very quickly realized that we can't use logged in user count to reflect any sort of hits against the database. Because with web and with client server, users often leave the system just running. And like they walk away, they go to the washroom, get a coffee, they come back, they click 3 buttons and they walk away, come back, talk to Mary, whatever it is. So this is telling us, this one breaks us up into the who's are active in the last 5 minutes, last 15 minutes, last 30 minutes, and last 60 minutes. And then also I can see which URL they've last hit. So just to give a sense of what activity is being going on. Part of that also, and this is just capturing the information, understanding load is we capture on a daily basis. We capture, I'll go up here so you can see. For each day, how many successful login attempts, how many people actually logged out. So this is a Saturday, I guess a Sunday. 29 people logged in, only 9 logged out, 16 timed out. How many failed with a bad password, failed with a bad user. So they had the right password. Sorry, this one, right user, wrong password. This one, user, I don't understand. And then how many times, so users can be marked inactive. So this tells us how many actually try to log in and the user is inactive. So it's a way of going back and getting a sense of how heavily a system is being used. Because sometimes we don't find out about things until days later. And then we have to go back and look in the logs and figure out what's going on. Active processes. This is actually surprisingly useful. We will get the odd situation where a process gets stuck. And so you can see it running and the time goes up and up and up and up. It also gives you a sense of how busy the application, so there's web processes running, and then up here I actually have a count at how many web processes are running at that particular time. So if I'm in here looking at something and I see a number like 12 or 15, then there's a problem, because each of these things are taking sub 300 seconds to execute, and so if you've got like 15 of them going, there's something has happened. Like that's a lot of people coming in the same second. You'll notice that we also have some preemptive processes. Fantastic, very good. Things like we've got logger, so all of our log messages are done through a preemptive thread. We have an audit event cacher, so basically we are watching certain fields, and so when somebody changes that field, we throw it into an array, and then it gets passed over through a call worker to the audit event, and then it takes it and throws it into a database, and it gets stored and put here, and it ends up getting remote off to another server. But it's all handled outside, and what this has done is we used to have a lot of, looked like a comb, and now we have a very, very stable performance lines and only the odd spike. It's taken out a lot of the weird behavior that you couldn't explain. Everything else is great, but all of a sudden it's like we just sucked for 2 seconds and you don't know why.
So these logs are just another database that you're accessing to view the data in?
Our logger, so actually, I should mention that. On the zip file that I gave, there's a component called ih_log. Yeah, and that is the component that we use, and it's got preemptive logging all built in. So there's a call that opens up a dialog window, and then you can just basically start throwing logs at it, and it throws it into the process, and it writes it to disk when it gets a certain number of cached events. So it's quite interesting. Yeah, it's good to look at. It's worthwhile. It's really worthwhile looking, especially if you're in a server. It's worthwhile looking at the preemptive threads. Yeah, and I'm trying to push printing into preemptive threads. We don't print through print drivers. We use PHP, which is obviously not preemptive, but we're looking at using like a Lambda function or something, and then calling that, because our printing is queued, so it's not live. So it takes 2 seconds. It takes 200 milliseconds. It doesn't matter. Just let it go off. But then I could do preemptive by using a Lambda function and using a web process. Okay, so now we're getting into some of the interesting stuff. Memory. There is a new command called cache info, I believe. And this table, which is, and this I've got the code for it in the zip file as well. Unfortunately, it works better on a bigger screen. But what I have is it's telling me how much of my cache is being used. So 4.16 gigabytes of my cache, 5 gig is being used. It's giving me the ratio between table data and index data. So 26% of my cache is in table data and 67% is in indexes. On this side, I've got my tables. And so here I can see, so records bytes used in this column. So I know which table it is too. It'll be the treatment table. So 20.371% of my cache is used by data on this table, and 57% is used by indexes from that table as well. So the vast majority of my data, my cache, is being consumed by a single table. Unfortunately, we have to have 7 years of data, so they run queries and it runs against anything. But this tells me that I should break this into 2 tables. There is the current data table, and then there's the archive version of that table. And then all of a sudden, my memory usage would change completely. On the right here, this table it shows you each individual index, and it's telling you how much is being used, which is useful sometimes if you're. So this is an under stress index, cache. Normally, this should be more like 35 to 45%. That is typical. So, and I know this because of watching the system, that this when the indexes go up and the data goes down, that there is a little bit of stress going on, and it's contention. It's doing some contention, and it's starting to toss data out that really shouldn't be in there. So this is a more long-term thing to try and fix, but this is really interesting to see that when your system is not performing well, what does the cache look like? So I can add more cache, and that'll help. More data will come in, but it's interesting to load, which leads me into this. So in the document that I did, I talk about taking things like looking at page performance and in 7 or 8 iterations that I went through to improve my measurements and how I interpreted those measurements over time, okay? So I'm not going to show it to you in the order that I did in the document. I'm just going to show it to you. So I've got a number of graphs, and so what this is showing you is it's showing you a 24-hour period. I'll zoom in a little bit. Try to find the right place to zoom in. No, I'm going to zoom in right over here. So it's showing you a 24-hour period. In this case, this is average, all pages, the entire system over 24 hours. There's a data point every 5 minutes. This yellow line represents right now. So anything to the right of this line is yesterday. Anything to the left of the line is today in blue. And the gray line is yesterday. Sorry, last week. So I'm comparing in this case, a Tuesday to a Tuesday, because we are dealing with schools, and so I can't compare a Monday to a Sunday because it's completely useless. So what this is telling me is that right away I can see that the pages are slower today than they were last week, and it's sizable. There's a sizable difference. Okay, so which would make me think what's going on? Actually, it's really convenient of doing today. This graph down here now is starting to, it's not looking at averages anymore, it's now looking at 80th, what is 80th percentile? Okay, yeah, 80th percentile and 95th percentile. So just to make sure I'm clear what I mean by that, so if I serve 100 pages, I sort how long each page took, and I go to the 95th spot in that 100 index, 100 length array, and I take that value, that's 95th. I take the 80th spot, that's 80th. So if I have, let's say I serve 99 pages at 2 milliseconds, and the last page at 6 million milliseconds, my 95th percentile is 2 milliseconds, my 80th is 2 milliseconds, and my average is going to be, I don't know, 2.5 million, whatever it's going to be, right? So you have to start, averages are really easy to type, but they're mostly useless because it's too broad. So like in our case, our performance metric is 85% of the page, a page is rendered in 300 milliseconds on the server 85% of the time. So we allow for edge cases, that's reasonable, okay? So this number, so in this case, it's the green bar, that's the number that's most important that we're really monitoring. But then we want to know the 95th, because when the system starts to behave badly, you'll see those lines will start to pull at different times. I'm just going to go to the next one, which is maximums. And so here, this is showing me the maximum for each one of these things. And these graphs are capped at 1,000 milliseconds. This one doesn't. It just goes to whatever. No, actually, I might have capped it at 10 seconds, because beyond that is crazy. So we will see maxes all the time for whatever's going on, because we have some scenarios where the administrator wants to do some massive function, and we just make them wait. And sometimes it takes 40 seconds, and they just wait, and they know, and it's fine. But it'll skew the graph. But it won't skew the 95%. Because the 95%, it's outside of that 95%. As long, so if all of a sudden you see your 80th percentiles and 95th percentile start to bleed, now, you know what? The users are noticing. It's degrading enough that the users are noticing. So it's not, now you're looking at the data. Now you're taking that data, and all I'm doing is measuring, on web connection, milliseconds, and I'm just about to end milliseconds, and that's how long it takes me to generate the page. And so from that, I can start getting more information. So there's no network traffic here. There's no firewalls and whatever kind of garbage it has to go through. That's not part of our metric. This one is giving me users. So that, 15-minute, 30-minute, 60-minute active. So this is showing me how many people are kind of active on the system over time. And this is showing me how many pages have been served. Okay, so now, remember we talked about above that there's a big difference between last week and this week and how long it's taking? Well, now we're seeing the same differences in how many pages are being delivered over time. So this is when that person was trying to hack the system. So, 1,700 pages in 5 minutes. Our normal stuff is not anywhere near that. But it's still a good number. So this is in the 5-minute cycles. And so there is a big difference between the number of pages, spring break, last week, and this week. So Colorado is on spring break. So last week, the system was hardly being used compared to what it is now, which is normal. So I get a sense, okay, no, it's reasonable to see. It's gone back to what it should be, what's going on. This is showing me the cache. And so we do flush our cache at night. We have a lot of stuff that goes on throughout. There's a midnight data maintenance run, outage reports. This is data that's time sensitive, so it's our time based. So we have to run these queries and update statuses and stuff. And so we take the cache here, which is what the users put in there based on their priorities, and we totally messed it up and now base it on system maintenance, which means that this cache, if we left it here, is completely useless to the users, and it caused lots of problems. So we solved it by basically flushing it. It looks like something else going on, and then there's a little bit of a preload code that runs in and tries to load things that are relevant, and then we let it load up over day. Yeah?
How do you flush it?
There's a flush cache command, and you can pass it a star or you can pass it a 0, and it'll flush.
There is two concepts. There is a flush itself, which is not purging the memory, but is saving the content of the cache on that storage, and there is a purge of the memory.
Yeah, if you pass a star in flush cache, it'll empty it. It'll empty all of the data for sure. And I've seen times where the indexes don't necessarily get flushed. I think it's mostly a standalone thing. So in our own development environments, it doesn't behave the same way as it does on server. On server, it's very aggressive. It'll flush. But we have seen scenarios too where we flush it and it doesn't go to the bottom. And then tomorrow we flush it and it's a little bit higher, and then a little bit higher, and it's like, okay, something's going on. And we've seen that too, and we just it's signal to restart the server. On this last graph, we can have lots of print jobs, and so we just count no when print jobs. So we use that as part of when the system starts, because we used to use the system drivers, and don't use system drivers for printing. Just don't. It's a bad idea, especially if you're on Windows. On Mac, it's much better. They do a much better job of sharing the processes, but Windows, it can lock up your system. And we had print jobs going from 3 seconds to 15 milliseconds, and that's like, and we have our own PHP interpreter and so that's me invoking it through the command line, running a PHP script, and doing all of that, and it's 15 milliseconds compared to 3 seconds. It's so much faster, and the PDFs were like a fraction of the size too, so it's really awesome. Print, so you see there's a lot of information that we have here that I'm looking into what's going on under the hood. So this is not to do with user metrics, it's system metrics, right? Like what's going on? So, I don't feel well. Okay, the first place we do is we come here. So what's going on? Do the graphs reflect I'm not feeling well? The system is slow. Does it reflect it, right? And then if we need to, we can start digging in. So here I'm showing all of the print jobs. So this is a summary of the last 30 days. I show how many print jobs. And so this is, I don't know if you're familiar with the concept of a heat graph. So I've got, this is kind of graphed out over time in blocks of time. And so I can see where the bulk of them are. And then I sum them up on the ends, 50th percentile, 85th percentile, 95th percentile. So I'm looking for opportunities of improvement. So obviously this is a slow report, but there's only 8 of them in the last 30 days. It's fine, right? I'm not going to invest in it. Well, wait a minute. This one, there's been like 1,100, but 1,000 of them have been sub 100 milliseconds. So it's like, it's okay. So you start putting your effort where there is need, as opposed to, that just bugs me that it's slow, so I'm going to fix it. Well, if there's only 2 people using it, it's a waste of your time. You can do other things. And then I've got individual print jobs over the last little while that it's all listed there. Yeah, okay. So I've got a similar thing for the URLs. Let it load. The network is slow. It's not usually this slow. Oh, you know what? I'm not going to use CO2 since we had CO1, since we had that guy throw in 1700, and I'm going to say guy, because girls are too classy for that. So there's a table where all of these are stored, and so it's collecting it. The first time it's a little bit slow because there'll be thousands.
While you're waiting on that, are there aspects of this performance that are captured in some particular analytical way to identify hacking?
Our system is like there's no public access to it. Internally in the system, like the way we've implemented things, I've got like the forms, right? So we're dealing with medical data on students. And so if you were to say, I want to look at a student's data, and if you were going to go into the HTML and change, IDs and stuff, it's not going to work. Because I don't use, the field names I use are encoded, and then there's basically a hash on that key that's part of that. And so they all have to align. So I have a couple of layers of things that I'm doing to cross-check and stopping people from doing some of that stuff. And so it's very involved. And it has to be really, really deliberate. Okay, so what this page is showing is the same sort of thing that I had done with a heat graph of the print jobs. I've got a similar thing that I put together on each of the URLs. So there are many, many pages that we're serving. So you can see like the home page, and so this is telling me this is slash, and whether it's a get or a post. So that's what that is. And then it's telling me, unfortunately, you can't see the whole thing. But here is the number of requests, and then over this, sorry, as I'm sorting, over these columns is telling me how many times that request was met within that list. And then on the right here, I have my mins and 95ths and maxes and averages. So if we're going to go down to, I'm going to go down to here. Yeah, so here we're getting to something where, so there we go, that's a little bit more heavily used. So we can see down here that, so like this is 1,100 times, but this drifts pretty long into the higher speeds. And so I think this is like 2 to 3 seconds. So that's really, really long. So this would be a candidate page for me to go look at. And then I look at this. I know what this is. This is a longer problem to fix. But when we're having performance problems, then what I'll do is I'll come into this page and let me go back up to page 1. And then I'll sort on 95th percentile. And so now I know this is the worst performing page, 2,783 milliseconds, 363 times. And yeah, so now I can see, you know what, this number is too high, so this is an area that I'm actively working on right now. And so it gives...
Store those URLs, how do you update them? Do you store them in the data file?
Yeah, and so what happens is that every day, there's a table where every request that comes in, I have the URL, I have the user, there's a district ID, and I know how many milliseconds it took. And then if it is slow, okay, here, this is actually a direct view into that table. And then every night at midnight, I take that table, I flush it into a file on disk, and then I have that in all history. So I have this for, I think, 3 years, this data. So I can go back and say, okay, this particular page, how long has this been going on? And I can collect that data. It's work, but I can do it. So this is telling me all of the URLs that have come in. So these ones, I caught it mid render, what do you want to call it? So it hasn't finished, but it's enough to start. If it's outside of my metrics, so this is more than 300 milliseconds, it goes orange. And if it's more than 600, it goes red. This is part of the knowing what you're measuring. So I say it takes 300 milliseconds to render. So I'm in a cooperative processes, the web processes. So if it takes 301 milliseconds, using the millisecond command, is that actual CPU time? Or is that because some blocking thing blocked for 250 milliseconds and I did this in 40 milliseconds? So I actually capture both milliseconds as well as the CPU time. There's a command to get off the process, process state, process properties, and you can get the CPU time. And so if CPU time is more than 1 second, then what I do is I actually log a bunch of additional information and it gets thrown into the slow URLs. which gets you into the last piece that I want. So I actually am profiling methods. So I have a profiler start and a profiler stop, pass in the method name, current method name, and I know execution time of that method. I don't do all methods, I just do some of them. And I gave you that components in there as well. And so this is an output. So I have my on web connection. Everything is clean and pristine. I capture my times at the end. It's, oh, CPU time was more than 1 second. Then I say, okay, give me that log of the methods, the profile of that method execution, and it gets dumped into along with the information. So I know in this case, it looks like this method took 802 milliseconds. And it was 1,000 milliseconds in total. So the vast majority is here. So somebody went in and created a calendar, and that calendar caused a bunch of treatments to be created. So this is potentially a candidate to spawn off into a worker process, and that means that this would have returned in less than 200 milliseconds, which would have been successful. So this starts to identify bottlenecks. I can continue on down, and I'll talk about that. So here's another one. Yeah, so this is 5.5 seconds to do this one, and that's a query. It's just a horrible query. Users want it, it's like, okay. So it's a discussion, we're still working on it. So it starts to give me a sense. So now I know, I see a pattern. You know what, this calendar weekly URL is slow, because we saw that earlier. And now I can say, you know what, it looks like it's this piece. So now I'm able to, and what I knew is this is the name of the method, and I added extra profiles to try and figure out where in the method, what part of the method is the problem. So this is just temporary. And now it's like, okay, I know where it is now. There's something in here. So can I optimize the query? Can I do something? Do I put something in a worker? Do I create a status table and pre-calculate every night? Is it like I can start weighing what's the benefit? But now I have evidence. I don't have to look at anything else. There could be 2,000 lines of code that's being executed, and I'm looking at 4. Right? But I've measured it. I've got proof. I've got proof. And if I fix it, tomorrow, that number will be 4 milliseconds. It's good. Like, I measure and then mitigate. So trying to find out the right measurements. Now there's 2 different forms here, and I do want to show this. Okay, I'll be really quick here. So this is showing you basically just a list of the methods that were called, how many times they were called, the average time. This is showing you more on the idea of a flame graph. So what it's got is there's really a stack trace that's built in. So I started with on web connection, and then from that, oh, this is a sub one. Then I went into web connect handle request, and then I went into web connect based on. So now I can see, so this is my stack depth. Now I might have a method called here and here, but this one might have taken 2 milliseconds, and this one might have taken 600 milliseconds, and it could be just based on where it's called, what parameters are passed. And I don't want to look, I want to know what's the context for that call to fail. This gives me context of what code, because we often will have code that says, take this data and write it to disk, and it's called everywhere. And in one scenario, it tanks, and you don't know why. You don't even know where it is. So this is giving me that context. Okay. Right. This gives me access to the entire method profiles. So I'm going to go into tab bar. Yeah, tab bar 2. Yeah, so this is a particular method. It's basically rendering the tabs on top of one particular page is heavily used, and it has to decide if it needs to put up warning indicators. So there's queries running all the time on this thing. And so I can see on this bar, it's been called 14,000 times, but a total time of 61 seconds. That is a problem. It's being called a lot. So there's yes, it's only 4.5 seconds, but there are times when it's really slow. So there's an opportunity there for doing some tweaking, right? So it helps to look at things, but it's very, very high level. Okay. So what I can do, I'm gonna go back into this. So look in the document that I sent. It talks about the flame graphs, and I got a sample in there, but I want to show it to you. And so I have the profile component writes this information out. So I have a setting that basically says every time a URL comes in, I want you to write it out. So it writes it out to a file, and the file gets very, very big. Okay. And then I have a process that'll go in. Yeah. So that's in this flame graph example. And then what it does is in the component, there's a method to call and to fold that file. So what it does is it takes all of the similar lines, so like it's a similar stack trace, and it sums them all up and puts them in a single line. So it'll take an entire day, and so this is what I've done. So this represents an entire day of the server running, and I'm able to collect it all together and basically produce, where is Safari? This flame graph. So this represents a full day's execution, every single method call, and it's all relative. So I can right away see this, and I'm going to click on it, which means it's going to zoom in. This represents 32%, as now I hit it, 32% of my day's execution. So inside that 32%, what was running? Oh, this after hours processor was running. Well, I can dig into that. And so now I'm able to dig in and start to see, so of that, how much time, so you're able to see relative time. But what that helps me is, so here's my web connections. So it's easy to see which page is taking up the most amount of time here, right? So this page is taking up the vast majority of that time, of that slice that it's spending in this method. So now I can say, this is a place that I can go in and start looking at what's the time. But I can see that the vast majority of the time is actually spent in this one piece, and then now that gives me a place to go look in my code to say, okay, what is being done? So I might have a method that I'm calling 600 million times. It takes 1 millisecond to be calling all over the place. It's not going to show up here. It's only going to show up here if it's the cumulative effect in a particular place that it's taking up a vast majority of time. It's all clues, breadcrumbs. Okay, I'm done. I'm done. So please take a look. My email is on the end. Feel free to email me. Yeah, everything is there. Email if you got any questions. I do have some code there. I was pretty light on the samples. The components are pretty straightforward to use. So just look at shared methods and you'll see them. And I did give a little bit of code there. So. And they are open source, so feel free to use them in your own systems, okay? If you improve them, please share them back. That's why I'm sharing them, so good, thank you.